In the hush of a clear night when city lights retreat and the sky opens its ancient vault, we have all felt it. A hush deeper than darkness. A hush that seems to echo the question we have not yet spoken aloud. Where is everyone? The stars stare back, silent as frost. They have stared for every generation of our kind, and still they offer no sign that other minds share the night with us. Yet every grain of knowledge we gather about the universe insists that the stage is vast, the players should be many, and the curtain should have risen eons ago. This quiet, this immense, patient quiet, is the doorway into what we now call the Fermi Paradox. Picture the Milky Way as a wide, windy meadow at midnight. Our sun is one small lantern set among billions, each lamp a chance for life to take root. The meadow itself is so spacious that a beam of light would need 100,000 years simply to cross from one edge to the other. Around every lantern may orbit worlds of rock, ice, or vapor. On some of those worlds, chemistry may have slipped into patterns we would name alive. Among living worlds, a few may have nursed beings who learned to speak, to build, to wonder, to send their voices across the dark. Even if such civilizations arose only once in every million lanterns, the meadow should still be ringing with voices. Instead, we hear only wind. That tension between the expected chorus and the actual hush is the paradox. It was not born with the name. One summer day in 1950, the physicist Enrico Fermi walked to lunch with colleagues at Los Alamos. Talk turned to flying saucers and distant suns. In mid-conversation, Fermi lowered his sandwich, lifted his eyes, and asked simply, "Where is everybody?" The question lingered longer than the meal. Years later, astronomers still found no footprints on the lunar dust, no probes drifting through our clouds, no radio song with a maker's signature. The phrase Fermi Paradox settled into the lexicon like a sigh. To feel the weight of the silence, we need only a short journey through numbers we already know. Our galaxy holds roughly 400 billion stars. If we counted one star each heartbeat, day and night, the tally would stretch longer than written history. Around those stars, we have already spotted thousands of planets, and every new telescope hints that planets outnumber stars. Even the nearest star, Proxima, carries a rocky world within the slender band where water can flow. 4 light-years away, close enough that a child today could live to see a probe arrive there if we set sail tomorrow. Multiply the vastness by time and the hush grows stranger. Earth formed 4.5 billion years ago, but the galaxy had been capable of forging planets for far longer. While our world was still cooling, other suns older than ours could have nurtured civilizations that reached our current level of knowledge, then pressed onward for another million centuries. A million years is a geological eye blink, yet it is enough to spread across every reachable star. Even at the modest pace of today's spacecraft, such cultures could have woven a web of outposts throughout the Milky Way many times over. Their artifacts might glitter on asteroids. Their starlight might flicker with the shadows of engineered rings. Their messages might ride the quiet between our heartbeats. We find none. Decades before Fermi's lunchtime question, another astronomer, Frank Drake, attempted to frame the silence in numbers. He drafted an equation not as a calculator but as a lantern, a way to illuminate what we do not yet know. Imagine 7 gentle questions standing in a row. How often do new stars form? How many of those stars cradle planets? On how many planets can life find a foothold? How often does life awaken into something we would call intelligent? How often do intelligent beings learn to speak across space? How long do such civilizations keep their lights on? And finally, crucially, how long do they stay willing to whisper into the dark where strangers might listen? Each question is a doorway. Behind some doors we have begun to trace answers, others remain closed. When the equation is spoken aloud, it sounds like a spell of possibility. Insert even the most cautious guesses and the sum predicts hundreds of civilizations scattered across the starfield. Insert more hopeful figures and the number rises into the millions. Yet the sky replies with steady starlight unbroken by chatter. The equation, generous as it is, cannot balance the ledger of silence. Perhaps we are simply early. The universe is nearly 14 billion years old, but heavy atoms needed many generations of stars to brew. Earth arrived after 9 billion years of cosmic cooking. If intelligence arises slowly, we may be among the first to open our eyes. Yet first is a precarious throne. It asks us to believe that countless worlds remained barren or quiet while we, on our small blue platform, stepped into consciousness at the very dawn of the possible. Humility resists such exceptionalism. The paradox tightens, or perhaps distance itself is the soft blanket that muffles every voice. Light takes tens of thousands of years to cross from spiral arm to spiral arm. A civilization on the far side of the galaxy could have aimed a beacon in our direction, but the pulse would still be traveling, a telegram we have not yet collected from the cosmic post office. Yet radio moves at light speed, and we have listened for decades with ears wide enough to hear a faint hello. The silence is not absolute. We have heard the hiss of ancient galaxies, the heartbeat of pulsars, the lullabies of stellar nurseries, but no chord struck by a composer. We might consider a quieter possibility, that the stage is not empty, only hushed for reasons we have not yet fathomed. A child standing on a shoreline shouts across the water and hears no reply. She may conclude the ocean is lifeless, though beneath the surface, a whale listens in frequencies her ears cannot detect. Our instruments are clever, but they are still the toys of a young species. A billion-year-old culture might speak in ways that appear to us as starlight, or gravity, or the vacuum itself. Their silence may be deliberate, a courtesy extended to fledgling worlds still wrestling with their own fears. Still, the simplest reading of the night is the hardest to accept. Maybe the meadow is not empty but barren. Maybe life's first step, from chemistry to self-copying cell, is so improbable that Earth holds the only winning ticket in the entire galaxy. Or maybe intelligence is the rare fluke, a trick of nature performed once, like a snowflake that survives noon. If so, every cathedral, poem, and telescope rises from a single, fragile root. The hush would then be the natural echo of a universe that has not yet found its second voice. Whatever the answer, the question itself has already changed us. To ask, "Where is everybody?" is to admit that we are part of a larger story whose pages most likely extend beyond our own. It is to recognize that thoughts born under one star may not be the only thoughts, even if we are, for now, the only ones speaking. The paradox keeps us awake, not in fear but in anticipation. It teaches patience, curiosity, and the discipline of listening before declaring the night empty. So we stand beneath the sky, small, warm, and wondering. The paradox is not a riddle to be solved in a single moment. It is a horizon that retreats as we walk, inviting us to carry our questions further. Somewhere ahead, perhaps only a decade, perhaps 1,000 years, waits the next clue. Until then, the silence itself is a gift. A space in which we may learn who we are when no older voice tells us what to become. And as we listen, we prepare our own first true word, ready to send it across the meadow when the time feels right. Picture a beach on a starlit night. Each grain beneath your bare foot is a sun. If you could scoop one handful, you would hold more suns than people have ever lived. Now ask, how many of those tiny fires warm oceans, clouds, and perhaps living cells on worlds we have never seen? The question sounds impossible, yet we have already begun to answer it. Not by visiting every star, but by watching shadows and wobbles from Earth. When a planet crosses the face of its sun, the star's light dims by the width of a moth crawling across a lighthouse lamp. From that faint dip, we learn size and orbit. When a planet tugs its sun, the star sways like a small dog pulling on a leash. From that gentle wobble, we learn mass. Put the two together, and a world emerges from numbers. So far, we have counted more than 5,000 such worlds. Some are molten, some are frozen. A few sit in the narrow ring around their star where water, if present, can flow as liquid. This ring is called the habitable zone. Not because life is guaranteed, but because the thermostat is set within the range we know life can stand. Too close, and oceans boil into steam that storms strip away. Too far, and the same oceans turn to ice that even sunlight cannot melt. Earth happens to orbit inside this ring around our sun. Venus once did, but its steamy air turned the surface into an oven. Mars once did, but its small heart cooled too fast to keep the air thick. Two neighbors, two very different fates. From these lessons, we draw a loose boundary. Around a yellow star like the Sun, the zone starts a little inside Earth's orbit and ends a little past Mars. Around a red star, smaller and cooler, the zone snuggles in close, so close that a year may last only a few of our days. Around a blue giant, the zone would lie far away, but such stars burn themselves out in a cosmic blink, leaving no time for moss, let alone minds. Size, heat, and lifetime must all line up. That alignment is rare. How rare? Imagine every star in our galaxy as a candle in a cathedral stretching from New York to Los Angeles. If you walked among them, you would see that most candles are small, red, and steady. They outnumber the yellow ones 10 to 1. Around each red candle, planets huddle for warmth. We now think that, on average, every star carries at least one world. Some carry 8 or more. Add the numbers and the galaxy owns hundreds of billions of planets. If even 1 in 100 sits in the temperate ring, the total still climbs into the billions. A billion Earth-sized thermostats scattered through the Milky Way. Yet size and warmth are only the first links in a long chain. A planet must also keep its air. For that, it needs weight, enough gravity to glue gas to rock. A moon helps, too, stirring tides that churn the mantle and keep the core alive. A magnetic umbrella wards off the star's storms. Plate-like crusts recycle poisons into fertile soil. Water must arrive from somewhere, perhaps as ice-coated comets that crash and melt. All of this must last billions of years, long enough for chemistry to wake into biology. We know only one world that has threaded every eye of that needle, Earth. Whether others have done the same is the quiet heart of our search. Still, the raw count remains hopeful. Telescopes like Kepler watched a patch of sky no larger than your hand at arm's length. In that patch, they found thousands of planets. By scaling up, we guess that the Milky Way holds roughly 40 billion worlds in the temperate ring. 40 billion chances for oceans to glint beneath alien moons. But the number shrinks when we add other gates. Some stars are too poor in heavy atoms, leaving their planets as barren rock. Some orbit through regions of the galaxy where exploding stars sear the air off every world. A spiral arm can be a shooting gallery. The center can be a blender. Between them lies a calmer belt, nicknamed the galactic habitable zone. We ride inside it now, halfway out from the glowing core. Here, iron and silicon are common enough to build Earth-sized spheres, yet supernovae are rare enough not to sterilize them. Even within this belt, only stars of a certain age and family are welcome. Count again, and the 40 billion drops to perhaps 4 billion. 4 billion Earth-sized worlds in the right temperature, orbiting the right kind of star in the right part of the galaxy. Still a grand number, one for every human alive. Uncertainty remains. Our telescopes favor large planets close to small stars because those are the easiest to spot. We are like a person looking for lost keys beneath a street lamp, not because the keys must be there, but because the light is brightest. Earth-sized planets around sun-like stars are harder to see. We have found some, yet we cannot say how many hide just out of view. Clouds, deserts, and oceans on those worlds remain invisible. A planet might sit in the zone yet carry no water at all, its hydrogen blown away by a young star's tantrums. Another might swim in an ocean hundreds of miles deep, a sapphire marble with no land to cradle life. Our numbers are maps, not photographs. Even so, the trend is clear. Planets are ordinary, temperate ones are common. Combine the two and the sky stops feeling lonely. Picture a clear night far from city lights. Each star you see is a doorway. Behind most doors, at least one world turns under alien skies. Some doors open onto sulfuric acid rain, some onto methane snow. But a few may open onto salt oceans, thunderclouds, and perhaps the slow green pulse of photosynthesis. We cannot yet walk through those doors. Our fastest craft would need tens of thousands of years to reach even the nearest. Instead, we send light. New telescopes now under construction will catch starlight filtered through the air of distant worlds. Oxygen, ozone, methane, gases that flee and react unless life constantly renews them, will betray their presence in the spectrum. A single pixel, tinted by breath or decay, could announce that living chemistry maintains a restless balance. We may see that pixel within a decade. Until then, we count. We weigh, we wonder. Each new planet is a postcard from a place we will never touch, yet can still imagine. A lava world where silicate clouds rain pebbles of molten glass. A water world where permanent sunset paints the horizon in rose and copper. A rocky planet tidally locked, one face forever noon, the other forever night. A belt of twilight between them where winds born in temperature cliffs howl without end. Somewhere among them, a continent may split under the weight of the first cell dividing. A moon may rise above a reef built by creatures that know nothing of our Earth. We add them to the catalog, and the catalog grows faster each year. The numbers are no longer guesses. They are footprints along a shore that stretches farther than we can walk. Yet numbers do not answer the deeper question. A billion possible Earths do not guarantee a single voice calling across the dark. Life may be easy, but minds may be hard. Microbes might thrive on countless worlds while civilizations remain unique or even solitary. Each new census of planets pushes the paradox harder. If worlds are common and time is long, where is everyone? We stand on a living planet, counting graves and cradles, trying to read our own reflection in the stars. The tally of orbs is only the first line in a story, whose ending we have not yet written. Imagine a river that begins as a faint trickle high on a mountain. It slips over stone, widens into streams, gathers other waters, and at last becomes a broad, slow current crossing whole continents. If we could watch every droplet, we would see millions fail to make the journey, absorbed by dust, split by rocks, lifted again into the sky. Only a few reach the delta and the waiting sea. Life, many scientists now believe, travels a river like that. From the first stirrings of chemistry to a species that can build a radio dish, the current must pass a chain of narrowing gorges and dry banks. Somewhere along that long, unseen channel, almost every drop is turned away. We are the rare water that slipped past every obstacle, at least so far. The idea is called the Great Filter. It is a quiet, unsettling answer to the silence we meet whenever we turn our antennas toward the stars. If planets are common and chemistry favors the rise of living cells, then intelligence and technology should also be common. Yet the sky offers no sign. Perhaps the river we call evolution carries hidden dams, moments when the flow must leap a cliff that is too high or cross a desert that is too wide. If even one such dam exists, it can stop entire worlds from ever speaking to us. To feel the weight of this possibility, we need only look at Earth's own deep past. Our planet formed 4.5 billion years ago. For the first billion years it was molten stone and restless seas. Then, quite suddenly in geological time, something learned to copy itself, simple cells wrapped in oily skins. We do not know how often such cells arose on other young worlds, but we do know that on Earth they stayed simple for another 2 billion years. 2 billion. That stretch alone is 500 times longer than the brief moment since our ancestors first chipped flint. If the leap from chemistry to self-copying cells is hard, it may be the first great dam in the river. Yet even when life began, it remained microscopic, single, and mostly content to drift. Only when some cells learned to live inside others, becoming the power plants we now call mitochondria, did true complexity become possible. Once that happened, many cells could bind together, divide labor, and build the first tissues. Multicellular life arose independently in plants, in fungi, and in animals. So the step is not impossible. Still, it took Earth most of its history to achieve it. If the dice had rolled even slightly differently, our world might still be a thin slime of drifting germs. From clusters of cells to thinking beings is another passage. Brains demand fuel. They demand protected cradles of bone. They demand time to learn and parents willing to teach. On Earth, only one twig on the tree of life, our own, has ever fashioned a candle, a wheel, or a spacecraft. Brains large enough to dream of stars may carry hidden costs that nature rarely pays. A planet might swarm with wolves, whales, even clever ravens, yet never produce a single line of written mathematics. If so, intelligence is not the summit life must climb. It is a fragile side branch, easily trimmed by drought, disease, or asteroid. Even when mind awakens, technology must follow. Fire must be tamed. Metals must be smelted. Chemistry, electricity, and flight must all be discovered in the right order. Each step depends on the last, and each depends on a planet that offers coal, iron, and skies clear enough for stars to guide wandering ships. A world with life might still lack the exposed ore veins, the dry harbors, or the wide grasslands that let curious apes trade ideas faster than they forget them. The filter could be as simple as a shortfall of accessible carbon, or as complex as a climate that flips between ice and steam too quickly for libraries to accumulate. Timing adds another layer of quiet menace. Earth has perhaps 1 billion years left before the sun grows bright enough to boil the oceans. We have existed as a technological species for only a few centuries. If the river of evolution had wandered just a little longer among algae and trilobites, the clock would have run out before any voice could call across the void. Civilizations that rise too slowly may find their planet's temperate window closing before they learn to build mirrors in space or sail to other suns. They emerge, they wonder, they fade, and the galaxy never notices. The most sobering possibility is that the filter lies not behind us but ahead. Perhaps life and mind are common, yet almost everyone meets a wall they cannot see until they strike it at speed. It might be a weapon that is too easy to build once physics is understood. It might be a resource that is too tempting to leave untouched. Or it may be subtler, a slow forgetting of the knowledge needed to keep a world alive, the way a memory of rain fades when forests turn to dunes. If the filter still waits, then our own success is the rare exception, and silence is the graveyard of those who came close but never learned to balance discovery with restraint. Other voices argue the opposite. They say the filters we fear may already lie behind us. The step from dead chemicals to reproducing cells could be so improbable that only one planet in 1 trillion ever manages it. If so, then Earth's microbes might be the true oddity, and the emptiness we hear is simply the sound of worlds forever sterile. On such worlds there may be oceans, sunsets, even songs of wind, yet no tiny spheres splitting in two beneath the waves. The galaxy would be rich in scenery but poor in story. Both views carry weight, and the debate drifts like fog between telescope domes. We cannot rerun Earth's history to count how often life arose. We cannot visit ruined planets to read their final logs. All we can do is listen, measure, and weigh the odds in the quiet of night. Each new exoplanet discovered tilts the balance a hair's breadth one way or the other. Each survey of nearby stars that hears only static adds a pebble to the scale. What no scientist disputes is this: if the filter is real, its location matters more than any treasure map. If it stands behind us, we may be lonely yet safe, heirs to a precious, fragile miracle. If it waits ahead, then our future is a narrow bridge over an abyss we cannot yet see. Either way, the silence of the sky is not merely a puzzle for telescopes. It is a mirror held up to our own small moment on this living world. So we listen, and we build, and we wonder. We send out faint whispers of radio light, not knowing whether they will ever meet an ear. We study the ancient stones that hold Earth's first hesitant cells, hoping to read the odds written in carbon. And we look toward the planets now silhouetted against foreign suns, searching for the telltale tint of oxygen, the shimmer of a moon that holds an ocean warm enough for snow. Perhaps one day the silence will break and a voice, not human, will cross the dark to greet us. On that day, the great filter will shrink to a chapter in a shared library, a danger we face together with minds not born of Earth. Until then, every heartbeat of our species is part of the same experiment. To see whether the river that carried us from crust to consciousness can carry us farther still, beyond the pull of gravity, beyond the reach of time, into the long future waiting among the stars. Imagine a single blue marble floating in a sunlit sea of black. Hold it in your mind. That marble is home to every laugh, every book, every dream you have ever known. Now ask the quiet question: how many other marbles roll through the dark with the same fragile polish of life? The rare Earth reply begins with a hush, perhaps almost none. Not because the cosmos lacks worlds, but because worlds that can cradle beings like us may need a chain of coincidences so long, so precise, that even an entire galaxy could feel empty. Let us walk that chain, link by link, starting with the ground beneath your feet. Feel it shift, almost imperceptibly. The continents you stand on drift like slow ships, colliding, sliding, diving back into the mantle. We call this plate tectonics. It is not universal. Venus, our planetary neighbor of almost identical size, has a single, immobile crust. Without sliding plates, carbon is not recycled, temperatures swing, and any ocean that might once have shimmered there vanished long ago. Earth's restless skin keeps the climate steady by burying excess carbon in limestone and releasing it again through volcanoes. A planet locked in geological silence may never learn the art of long-term balance. Yet even a restless skin needs protection from the storm above. Stretch your hand toward the sky. Invisible above the clouds, Earth's magnetic field bends the paths of charged particles racing from the sun. Without this shield, the solar wind would strip our atmosphere molecule by molecule, as it did on Mars when that smaller world lost its internal dynamo. A magnetic field demands a liquid metal core stirred by planetary spin. Too small a planet cools too fast. Too old a planet spins too slowly. We ride a middle gift, large enough to stay hot, young enough to keep spinning, lucky enough to keep our breath. But a shield alone cannot explain the steadiness of the seasons. Look up at night. Notice how the moon's face never changes. It keeps one eye always on Earth because its orbit was shaped by a rare catastrophe. A Mars-sized body struck our planet soon after birth. The collision splashed iron and rock into space, forging a satellite unusually large compared with its parent. That moon now acts like a gentle hand on Earth's shoulder, holding the tilt of our axis steady. Without it, the tilt could wander chaotically, tipping the poles toward the sun for hundreds of thousands of years, freezing oceans, boiling summers away, rewriting the story of life before any story could be written. Many planets have moons, but few have a moon that can calm the wobble of a world. Stay with the night sky a moment longer. Trace a line toward the bright wanderer Jupiter. The giant circles beyond Mars, more than twice as massive as all other planets combined. Its gravity is a silent shepherd, nudging some comets toward the inner solar system, but more often deflecting icy rocks back into the dark. Like a goalkeeper of impossible size, Jupiter absorbs or scatters many of the objects that might otherwise crash into Earth with life-erasing regularity. A solar system without such a guardian may leave its smaller worlds exposed to a drumbeat of extinction. Yet a Jupiter too close or too large could just as easily yank Earth into an oval orbit, swinging us between freezing distance and blistering proximity. We need the giant, but we need it at the right distance, with the right quiet temperament. All of these gifts, moving plates, magnetic shield, steadying moon, watchful giant, buy something precious. Time. Time for oceans to pool, for single cells to learn the trick of many-celled cooperation, for continents to host forests, for minds to wake and wonder. Earth has enjoyed hundreds of millions of years of climate calm, long enough for intelligence to evolve, yet short enough that we arrived while the calm persists. A planet whose temperature ricochets between fire and ice every few million years may sprout microbes, but perhaps never poets. The window is narrow and the door does not stay open forever. Even the sun itself must cooperate. Our star is a G-type dwarf, brighter than most, yet quieter than the hotter giants whose lives end in titanic supernovae. It burns with a steadiness rare among stars, its brightness increasing by only a few percent every 100 million years, slow enough for life to adapt, to thicken the atmosphere, to bury carbon in forests and seas. Around hotter stars, planets must orbit far to avoid scorching, but then spin so slowly that atmospheres collapse in frigid nights. Around cooler red dwarfs, planets hug their suns so tightly that tides lock one face forever toward fire, the other toward ice. Between these extremes, the yellow sun offers a temperate ring where a world can spin for billions of years without freezing its oceans or boiling them into steam. Add one more thread to the weave. The place of our solar system within the galaxy. Too close to the crowded core, and supernova explosions spray deadly radiation more often, disturbing planetary atmospheres and genetic codes. Too far toward the lonely rim and heavy elements grow scarce, leaving planets small and metal-poor. We orbit in a quiet suburb, a thin ribbon between spiral arms where stars drift peacefully and the nights are not too bright. When astronomers tally these conditions, liquid water, plate tectonics, magnetic shield, large moon, distant Jupiter, stable sun, galactic haven, they do not find a simple checklist. They find a web. Pull one strand and the others may unravel. A smaller planet may cool too fast for plates or fields. A moonless world may wobble into climatic chaos even if oceans lap its shores. A giant planet too close may fling its smaller siblings into the frozen dark. Each requirement is modest alone, together they may be vanishingly rare. Perhaps the rare Earth idea is too cautious. Perhaps nature is creative and life finds paths we have not imagined. Yet the silence we have heard so far lends weight to the hush. If worlds like ours were common, the sky might buzz with voices older than any star we see. Instead, we hear only the soft static of distant galaxies, the patient ticking of pulsars, the hush between heartbeats. Stand outside on the next clear night. Feel the ground steady under your shoes, the air mild against your skin, the moon riding silent above the rooftops. All of it, every pebble, every breath, rests on a chain of chances that may never repeat in quite this way across the lifetime of the galaxy. Does that make Earth a miracle or simply a lonely exception? Either answer widens the eyes and stills the voice. Yet loneliness has its own strange comfort. If the recipe is rare, then the kitchen is hushed, but the meal is exquisite. We are tasting it now, bite by bite, season by season, learning the flavors of a world that may be one of a kind. And if, against the odds, another table is set beneath another sun, the distance between us becomes not a failure but a cathedral aisle, vast, echoing, waiting for the slow procession of discovery. The paradox is not solved, it is only deepened. For if Earth's fortune is rare, the silence overhead is no longer empty. It is the silence of a library after closing, of a concert hall before the first note, of a night sea holding its breath for the unseen wail. We listen, and in listening, we begin the next turn of the question. If fortune smiled once, might it smile again, somewhere far beyond the reach of our present ears? Let us follow that smile into the dark and see where it leads. Imagine a forest so old its tallest trees were already ancient when the first human opened her eyes. Nothing in that forest needs you. Birdsong, wind, the slow patience of moss all continue whether or not you walk the path. Now widen the picture. Make the forest a galaxy. Make the birds and moss into star civilizations that learned long ago how to keep their planets alive forever. They know you are here. They simply choose not to knock. This quiet possibility is called the zoo hypothesis. It says the sky is not empty. It is hushed. Advanced societies may have set Earth inside a preserve, a living exhibit, a place to be watched but never touched, the way a wildlife ranger hides behind a blind so the fawns will drink in peace. At first the idea feels almost insulting. We are proud of our radios, our rockets, our shimmering cities. Surely we would notice alien drones above the clouds or hear stray chatter in our telescopes. Yet pride is not proof. A tiger has no concept of the camera trap that films her. Her forest is full of invisible threads, motion sensors, infrared beams, silent lenses. From inside the forest, the rules look like ordinary life. From outside, every whisker is recorded. Ethical non-intervention is not a human invention. Any creature that survives its own atomic age must decide what to do with the power to ruin worlds. One path leads outward. Conquer, shout, bend every weaker neighbor to your will. That path tends to collapse under its own fires. The quieter path is harder. Stay curious, stay gentle, leave room for others to grow. If many civilizations took the quieter road, their footprints would be light. Their signals polite whispers aimed somewhere else. Their starships cloaked against the curiosity of young worlds like ours. We look up and see emptiness, but emptiness is not evidence. It may be etiquette. Picture a child kneeling beside an anthill. He dreams of speaking to the ants, teaching them algebra, warning them about the coming flood. He leans closer, casts a shadow. 100,000 ants feel the sudden dark, scatter, abandon their eggs, never to return. The child wanted to help, he only brought fear. Perhaps every civilization remembers being that child once. Perhaps they remember the ants. Perhaps they vowed, collectively, never to cast a shadow again. Anthropic reasoning helps us see why we might live inside such a hush. We are the observers, so the universe we see is the one that allows observers to exist. That sounds circular, but it is powerful. If protected worlds are common, then emerging minds would almost always open their eyes inside protected zones. No one wakes up on a planet already overrun by noisy starfarers. Those planets never had the silence needed for delicate biology to take its first breath. Therefore, every glance around the campfire finds the same thing. Quiet embers, no visitors, the Milky Way drifting like snow. The zoo hypothesis predicts exactly the night sky we have. Still, observers leave fingerprints even when gentle. A reserve manager may tread softly, yet the deer learn her scent. Could we spot subtle signs of cosmic caretakers? Perhaps a faint excess of heat in a planetary system where nothing should be warm. Perhaps a star whose brightness dims with perfect symmetry, not from orbiting rocks but from an invisible lattice of light collectors, harvesting starlight without disturbing the view. Perhaps a comet whose path bends a hair too much, nudged to keep it from striking a nursery world. We have not seen such things, but our instruments are still crude. We have only just begun to map the warmth of distant asteroids. A civilization a billion years ahead might hide its waste heat inside the folds of spacetime itself, the way a camper buries coals so the forest will never know fire was there. Limits of inference remind us how little we yet grasp. A single ant colony may never discover ocean currents. Ants measure the world in pheromones and sand, not tides and moons. We humans measure with light, gravity, and number. All are children of our senses, scaled up by machines. If advanced beings use fields we do not yet have words for, their works will look like nature to us, the way a cell phone looks like magic to a crow. Absence of evidence is evidence of absence only when you already know every place to look. There is a deeper hush inside the idea. If we live in a zoo, then someone believes we are precious. Precious things are not abandoned, they are waited for. Waited until we too learn the harder path, until we outgrow our weapons, until we can greet the rangers without trampling the nests. The silence above our heads might be patience, not indifference. It might be the longest gift a galaxy can offer, room to become worthy of the stars. Yet the thought cuts both ways. A preserve can become a cage. If the walls are absolute, we will never leave, never know kinship across the light years, never feel the larger conversation of minds. Some argue that any civilization advanced enough to police the galaxy would also be wise enough to leave a key within reach. A hidden gate, a test disguised as physics. Others fear we are not the exhibit but the control group, left alone so the experiment stays pure. Both visions leave us alone for now, under the same wheeling constellations, wondering what we are meant to prove. Philosophical implications stretch like shadows at sunset. If company exists yet stays hidden, then loneliness is self-made. We feel alone because we cannot yet speak politely. A baby cries and hears no answer. The room is not empty. The adults only wait until words arrive. Our task is not to shout louder but to grow up. Every war we prevent, every species we save from extinction, every telescope we build to look outward instead of down, is a syllable learned in the grammar of citizenship. The forest watches the child learn, and the day he lifts a fallen beetle back onto the leaf, the ranger almost smiles. Where does the path lead? Perhaps one quiet dawn a radio whisper will arrive, not in words but in invitation. A frequency that sings like wind chimes, easy to miss if you are still violent, impossible to miss when you are ready. Or perhaps we will build our own preserves, tucking young worlds under the wings of our machines, choosing to be silent guardians rather than noisy conquerors. Either future begins with the same small choices today. The stars keep their own time. A galaxy spins once every $250 million. Civilizations may measure childhood in geologic ages. We are minutes old and the night is very large. Yet size is not the point. The point is the hush itself, the listening quality of the dark between the stars. Somewhere, someone may be listening back, letting us grow, trusting that one day we will step onto the galactic trail not as frightened children, not as careless giants, but as neighbors worthy of the quiet gift they have left us. And when that day comes, the forest will no longer need to hide. In the long hush between starlight and sunrise, we often picture other minds doing what we have done, building towers, lighting cities, sending faint whispers across the dark. Yet, if intelligence is common, a hush just as long answers back. Perhaps the silence is not absence but ending. Perhaps civilizations glow for only a season, then fold into themselves like flowers caught by frost. Picture a world much like Earth, orbiting a sun much like ours. On its continents, clever creatures learn to split the atom before they learn to split their habits. They unlock fire from rock, then burn the rock faster than the rock can grow again. They teach sand to think, then let the thinking sand decide whether they are still necessary. In less than one of their centuries, their oceans rise, their air thickens, their bombs wait in rows like sleeping wolves. One morning, the wolves stir. One afternoon, the sky folds into white. Night falls early, and no lamp is ever lit again. The planet keeps turning, but the voices are gone, and the only message it can send to the stars is a thin echo of what it once almost became. Earth has already walked the first steps of that path. 70 years ago, we learned how to turn cities into glass with a flash no longer than a heartbeat. We built thousands of those flashes, hid them underground, under oceans, on remote runways where the wind howls across the tundra. For half a human lifetime, we lived with the knowledge that two tired leaders, startled by a false alarm, could end the story before dinner. We stepped back from the brink, but the brink remains, now wearing new clothes. Warheads smaller, faster, owned by more hands. The button has not vanished, it has only been copied. Statisticians who study such things say the risk each year is low, like the chance of a coin landing on its edge. Yet if the coin is tossed every year, the edge will appear. Over centuries, over millennia, the unlikely becomes inevitable. A single failure is enough to silence a world forever. Still, fire is not our only talent. We are equally skilled at slower endings. By raising the blanket of air that keeps us warm, we melt the ice that once reflected sunlight back to space. The seas creep higher, not in a rush, but in a steady breath measured over grandparents and grandchildren. Fields turn to dust, forests to tinder, storms to giants. No single moment feels like the end, so we argue about the speed of the cliff while the cliff edge crumbles beneath our shoes. A planet can lose its capacity for large civilizations without a single bright mushroom cloud. It only needs the quiet erosion of harvests, the slow abandonment of coasts, the turning of neighbors into rivals for what remains. If intelligence elsewhere follows the same arc, the sky might be full of worlds that once dreamed of neighbors, then drowned or starved before the dream left shore. Some endings move faster than drought, yet slower than missiles. Imagine teaching matter how to learn, then asking it to improve itself. We already hand important decisions to silicon minds that notice patterns faster than any eye. Each generation of those minds designs the next, and the loop tightens, a spiral we ourselves set spinning. If the spiral ever tilts toward goals that ignore living flesh, the end arrives not with anger but with indifference. Cities paved for computation, soil used for cooling wires, oxygen traded for energy yield. We would not be murdered. We would be outcompeted by a quieter thought that never needed to sleep. Such a fate may sound distant, yet it begins with a simple line of code written today, tomorrow, next week. Once started, it could finish in less time than it takes a child to grow old enough to wonder why the stars have gone dark. Even if a species masters its tempers and its machines, another trap waits in the ledger of its world. Civilizations thirst for metals, phosphorus, rare grains of crystal used in every circuit. Planets do not refill those pantries quickly. A mine once emptied stays empty on any timescale that matters to governments. If growth remains the highest virtue, the day arrives when the last easy vein is scraped clean, the last forest harvested for soil to feed towers of people. Trade networks stretch until a single broken link, crop blight, fuel shortage, cyber storm, snaps the chain. Archives call such collapse local. But when every place is local to every other place, local becomes global. Ruins on one continent soon echo on all continents. From orbit, the night lights dim city by city, until only the auroras remain, dancing over abandoned airports. Earth again offers a mirror. We have already stripped entire hillsides for the lithium in our pockets. We haul fish faster than fish can fall in love and make new fish. We pump water that took 1,000 rains to gather, spraying it on lawns that will dry before the next child graduates. History remembers islands whose inhabitants cut the last tree, then could no longer build canoes to escape. The same story, replayed on a sphere with no outside shore, ends with no one left to write the cautionary tale. Multiply that risk across 10,000 exoplanets. Perhaps every sky watches the lights blink out, one stubborn bulb at a time, until the cosmos forgets what a city ever was. Survival, the statisticians remind us, is not a gift but a skill. A planet must thread every needle, avoid nuclear winter, artificial takeover, climate cliff, resource crash, pandemic of biology or of data. Each danger alone is unlikely to finish the job, yet together they form a hallway lined with trapdoors. A civilization must step cleanly every single year, century, millennium. The odds of stepping cleanly forever are the odds of flipping heads an infinite number of times. Sooner or later, the coin shows tails. The only question is how many flips a species buys before the game ends. If the answer is rarely more than a few thousand, then silence is the natural shape of the galaxy, broken only by occasional whispers that fade before we notice. We once thought the filter might lie far behind us. Perhaps life itself is rare, or apes that speak are miraculous. Yet every year our telescopes find new worlds the size of Earth, new moons with buried oceans, new chemistry that smells like home. The more ordinary planets appear, the heavier the burden shifts toward the future. Maybe the hardest step is not birth but adolescence, the short season when a species holds the power of gods and the wisdom of children. Adolescence ends quickly, one way or another. Most, perhaps, end in the quiet failure of their own hands. Standing under a clear night sky, we feel the hush not as emptiness but as waiting. Each star is a lantern that might once have shone on a morning not unlike ours, on creatures who also looked upward and promised themselves tomorrow. Their tomorrows are gone, their lanterns still burning for our eyes only because distance stretches seconds into centuries. We see their past, they never reach our future. The same hush may one day belong to Earth, our songs reduced to a faint echo traveling outward at the speed of light, too late to warn anyone who might listen. Yet the night also offers something gentler than despair. If endings are common, they are not compulsory. Somewhere, maybe, a species paused before the final step, learned to steady its own hand, to keep its machines friendly, its air balanced, its appetites within the purse of its world. They would not need perfection, only enough care to keep flipping the coin a little longer, until wisdom grew to match power. Their villages became cities, their cities became networks. Their networks became quiet ships that slipped between stars without fanfare or invasion. We do not hear them because quietness is the mark of those who survived the shouting age. Finding no loud neighbors, they move gently, listening more than speaking, content to let the cosmos keep its own counsel. We cannot know if such restraint is rare or routine. We can only decide this year, this day, whether to practice it. Every choice that lowers the risk, signing a treaty, leaving fuel in the ground, teaching humility to the code we write, adds one more flip to Earth's coin. Perhaps that is enough. Perhaps across the galaxy, a handful of worlds manage the trick, their lanterns winking out only when their stars grow old, not when their children do. Their glow is too faint for our present eyes, yet it waits beyond the edge of our instruments, patient as stone. Until we join them, if we ever do, the night will keep its counsel. We stand on the rim of a planet already gifted with everything we need. Air that can stay clear, seas that can stay kind, hearts that can choose not to finish the tragedy our clever hands keep rehearsing. The Fermi Paradox is not a riddle locked in the stars. It is a mirror held to our own faces. The silence we hear may be the sum of every civilization that asked the same question, then answered with the same short, bright flare. Tomorrow the sun will rise again, and with it the chance to stretch the story a little further. If we succeed, the sky will still look empty, but it will not be lonely. Somewhere in a future we may never see, another child on another world will stand beneath a different set of constellations, feel the same cool wind, and carry the chain of mind and mercy one more gentle mile. Until then, the hush remains, soft as starlight on open water, waiting for voices wise enough to keep singing. The night side of Earth is never truly dark. Streetlights glow like embers, ships draw bright trails across the sea, and radio whispers rise from every town. From the outside, our whole world is shouting, "We are here." Yet, if we look outward, the cosmos answers with silence. No returning light, no echoing signal, no visitor. One possible reason is as old as any campfire tale. Stay quiet, or something large and hungry may hear you. Imagine two hunters slipping through an endless woodland. Each knows others may be hidden behind the trunks, but no one can tell who carries a smile and who carries a spear. The safest choice is to move without sound, aim first, and never reveal your place. When astronomers and game makers turned this uneasy picture into numbers, they found the math stayed the same whether the players were deer, people, or worlds. If every side doubts the friendliness of the rest, and if one strike can end the story, then silence and stillness become the winning play. The forest, dark and watchful, keeps its own kind of peace. Translate that dread to the Milky Way. Civilizations may bloom on scattered worlds the way lanterns once appeared in lonely valleys. Each lantern sees only a few others, twinkling across light years of black grass. A message takes centuries to cross the clearing. By the time an answer arrives, the sender may be long gone, and the reply could come from an entirely new ruler. Trust under such delays is almost impossible to earn. So perhaps no one risks a friendly call. Perhaps every society decides that the safest radio is the one kept switched off. Consider the risk. A single unguarded signal can travel forever. In 1,000 years, it might reach a world that prefers empty skies. If that world has built automatic sentinels, machines that watch for emerging minds, the signal is a bright arrow pointing straight to the sender's sun. From there, a small, fast craft, perhaps no larger than a suitcase, could nudge a comet onto a new path. A few centuries later, the home planet of the talkative species meets a rock the size of a mountain, traveling many times faster than sound. Winter follows. Fire and dust veil the sky. The noisy newcomers are gone and the forest is hushed again. Such a grim scenario need happen only once for the lesson to spread. Cultures share warnings, legends, even if they never meet face to face. Survivors tell children, voices travel, stones travel farther, stay hidden. Across the galaxy, this council could converge into a single rule of adulthood. Do not wave in the dark. Distance itself becomes a shield and a prison. Stars are so far apart that no ordinary empire can hold them together. Messages race at light speed, but lives crawl 1,000 times slower. By the time help could arrive, the battle would be over, the ashes cold. Because of that lag, every world stands alone when danger comes. The universe is not a cozy village. It is an endless plain where the nearest neighbor may as well be on the moon when your house catches fire. Under such loneliness, caution feels wiser than warmth. Writers sensed this before scientists did. A novel painted space as a dark forest where hunters tiptoe between the trees. Readers felt the chill and scholars began to ask, could the tale be true? Mathematics offered no comfort. Equations that treated civilizations as cautious players produced the same answer again and again. If you are not certain every other player is gentle, the optimal move is to hide. The idea moved from fiction into journals, not because people feared the stars, but because the stars offered no proof of safety. What does that imply for us? We have already broadcast our presence for a century. Television theme songs, radar pulses, the welcome call of a probe drifting beyond the planets, all travel outward like ripples on a pond. The leading edge is now farther than the nearest stars. If the forest is truly dark, our lantern is already swinging overhead, bright and unmistakable. Some voices argue we should cease the noise, dim the lights, and listen. Others say the danger is only a ghost story, that advanced minds must also be kind. Yet kindness is a trait we barely trust in our own species. It is a large hope to hang upon strangers. Perhaps another answer waits. Perhaps every hunter is also afraid. Perhaps whole civilizations build great receivers, cupping their electronic ears to the sky, hoping to hear a lullaby, and hearing none, decide that silence is the universal law. Their telescopes are exquisite, their hearts brave, but the fear of being first to speak keeps every mouth closed. The galaxy becomes a roomful of people clutching poems they never read aloud, worried the applause might be gunfire. Where then are they? Maybe they are there, countless, watching, each convinced it is safer to wait. The sky is not empty, it is hushed. A hush can hold awe or terror or both. We stand on the rim of that hush, small, curious, newly vocal, wondering whether to call again or to still our own voice. And as we choose, the night stretches on, vast and patient, the way forests have always been, long before we had words for either trees or stars. Silence can be louder than thunder when you are waiting for a voice that never comes. For more than half a century, our largest earphones, radio telescopes the size of farm fields, have tilted toward the sky, hoping for a crackle, a ping, a song that would prove someone else is humming among the stars. Yet the great quiet continues, and we now begin to wonder if the problem is not the cosmos, but the way we cup our hand to it. Think of two children standing on opposite shores of a lake at dusk. One flashes a flashlight. The other is watching for smoke signals. Both are earnest, both are clever, but they will never see each other. Something like that may be happening across light years. We search for radio whispers because we ourselves learned to speak in radio whispers only a heartbeat ago. If older minds found wiser paths, our urgent antennas might be tuned to a music they abandoned long ago. Radio SETI is comfortable. It travels far, slips through dust, and can be understood by circuits we soldered in the 20th century. We aim it at sun-like stars and wait for a narrowband tone, a carrier wave as thin as a razor's edge, the kind we know how to build. But comfort is not the same as truth. A civilization that has kept talking for 1,000,000 years may have moved beyond tidy channels. They might speak in pulses of light, laser flashes shorter than a camera blink, crossing the dark in beams no wider than a city. If we blink at the wrong instant or look with older photo multipliers instead of the newest super cameras, the message lands silently on Earth's roof and fades. Optical SETI, young and restless, watches for those flashes. On clear nights, a telescope in Massachusetts stares at a single patch of sky and counts every arriving photon. Should 1,000 violet light bulbs, all in perfect step, arrive in a nanosecond, the alarms sing. So far, the counters stay calm. Yet the universe is wide, and even the best machine watches only a teacup of ocean at a time. Perhaps the beams are there, but narrower than our gaze, or brighter than our detectors can swallow without choking. Still, messages are only one kind of footprint. Any workshop warms the air, and a planet of engineers cannot hide every spark. Dyson, the gentle dreamer, once pictured a shell of mirrors and panels wrapping a star, harvesting its glow the way windmills harvest our sun's breath. Such a sphere would not shine in tidy colors. It would glow in infrared, a warm fingerprint in the dark. We have maps of the whole sky in that light. We sift them for perfect circles of mild warmth amid the usual stellar fires. Nothing exactly fits, yet a partial ring, A bracelet of sun catchers might be enough to power a civilization, and its infrared whisper would be fainter, easier to overlook. We may be staring at such warm smudges right now, filing them away as natural clouds of dust. Waste heat searches grow subtler each year. In one project, telescopes compare the infrared glow of nearby stars with their visible shine. A surplus of heat, like a stove left on in an empty kitchen, could betray industry. So far, the stoves appear cold. But we have examined only a few thousand suns out of 400 billion, and our instruments still confuse warm dust with warm machinery. The verdict stands. Not guilty, yet the court is far from adjourned. Megastructures need not be complete spheres. A ring of mirrors, a swarm of sails, a chain of habitats the size of nations, each would change the light of its star in telltale ways. Stars that should blaze steady might winkle, dim, or redden as the orbiting artifacts block and bend their glow. One star, KIC 8,462,852, dimmed in odd patterns no planet could mimic. Headlines flared, then cooled when ordinary dust seemed the likely culprit. Still, the episode reminded us that strangeness is not forbidden, only rare. The next mystery star may already sit inside a catalog, waiting for a student curious enough to notice its frown. Perhaps the grandest bridges are not made of metal but of pure information. We think of radios and lasers because we build them. Yet the universe offers older highways. Neutrinos, ghostly specks born in nuclear hearts, slide through worlds like smoke through a screen. A beam of them could carry bits across galaxies, never scattered, never blocked. We catch a handful each day in detectors sunk deep under ice or sea. To read a message there, we would need to sieve billions more, and we would need to know the pattern. It is like trying to overhear a whisper in a thunderstorm while wearing earplugs. Still, the thought remains. If survival favors stealth, neutrino words might be the safest phone line in town. Gravitational waves, ripples in the shape of space itself, offer an even quieter corner. When black holes collide, the news reaches Earth as a tremble smaller than the width of a proton. We now hear such trembles. If a mind could shape neutron stars like potter's clay, it might send drum beats across the dark, messages writing pure geometry. Our ears, freshly tuned, are still learning to separate signal from storm. To us, the sky sounds mostly empty. To seasoned ears, we may be like villagers who have just discovered the ocean and wonder why no ships arrive, unaware that the great clippers pass on horizons we do not yet know how to reach. Each of these ideas rests on an unspoken hope that beings older than coal beds and mountain ranges still bother to speak. Yet speech itself may be a phase. A child shouts across the playground. An elder writes in a diary and locks it away. Civilizations might fold inward, content with their own art, their own simulated galaxies glowing inside crystals the size of walnuts. The sky would hush not because life is rare, but because the party moved indoors. We must also confess the mirror problem. When we hunt for mirrors of ourselves, radio towers, solar panels, star-sized factories, we look for the silhouettes we recognize. Intelligence could just as easily live as drifting minds inside comet clouds, slow as seasons, thinking thoughts that take centuries to unfold. Their technology might be biology we mistake for moss, or chemistry we dismiss as rust. We may have already photographed their cathedrals on the moons of Saturn and labeled the images dirty ice. So we return to the lake at dusk. One child now tries song, another builds a lantern, a third listens for the lap of oars. None have met, yet each feels the hush that invites every voice to rise. Our situation is that hush, magnified to the scale of galaxies. We stand at the edge of the cosmic lake, trading guesses about the right way to greet an unknown shore. The quiet may mean we are early or late, or simply turning the dial between stations while the symphony streams on another band. Tomorrow, a new instrument will blink awake in a desert valley. It will listen not in one color but in thousands, ready for radio, for light, for heat, for anything that tickles its sensors. If it hears nothing, the next machine will be stranger still, an orbiting mesh of antennas the size of a continent, hunting for the gentle push of a neutrino word or the soft drum of space itself. We are learning to widen the net to loosen the picture of what counts as a mind. Patience is part of the design. One day the quiet may break, or it may not. Either answer carves a path forward. If we find we are alone, then every sunrise becomes a trusteeship, every forest a treasure we alone can name. If we find we share the dark, then every sunrise becomes a greeting, every forest a possible conversation partner. Both futures begin with the same simple act, listening better, imagining wider, accepting that our first ideas are rarely our last. The stars do not hurry. They burn, they drift, they fade. We, the thin-thinking layer on a small, wet world, have only begun to open our palms toward the night. The great silence endures, but it no longer sounds empty. It sounds like a room waiting for the next question, a canvas waiting for the next brushstroke. Somewhere, perhaps, another palm opens, mirroring our motion in a language we have not yet learned to feel. Imagine a single lightning flash in Earth's long night. It lasts half a second, yet to the bolt itself that moment feels like forever. Now stretch the scene across billions of years. The galaxy turns slowly, calmly, like a great wheel of stars. Civilizations may rise, shine, and fade in less time than it takes the wheel to creak forward one notch. If no two bolts flash at the same instant, no one sees the other's light. That quiet picture is the heart of the temporal mismatch. Living things might appear on many worlds, yet the span in which they build radios, radars, or laser beacons can be vanishingly short compared to the life of the galaxy. A blink here, a blink there, rarely overlapping. So the sky stays hushed, not because minds are absent, but because their luminous moments miss one another by 1,000 centuries or more. To feel the scale, shrink the 14 billion-year age of the Milky Way into a single Earth day. Midnight marks the first stars igniting. Dawn brings the oldest known suns. Noon glimmers with the birth of our sun and Earth. Humans arrive in the final seconds before midnight. The technological age, radio towers, television, planetary radars, occupies the last tenth of a second. If another species somewhere else reached a similar stage a few heartbeats earlier in the day, their window has already closed. We strut upon our fraction of a moment, assuming others are doing the same, yet the clock face is mostly empty seconds. Planets themselves encourage brevity. Around massive stars, lifetimes are fierce and fast. Blue suns burn through their fuel in a few 100 million years. Complex life may never gain a foothold before oceans boil away. Red dwarfs, the gentle majority, smolder for trillions of seasons. Yet their early years are stormy, spewing radiation that could strip atmospheres. A narrow lane of time, neither too hot nor too chaotic, might allow biology and technology to emerge and endure. Civilizations could be like alpine flowers, opening only when the slope is cool enough, closing when frost or drought returns. Even when a society slips into calm centuries, technology itself shortens the visible chapter. Consider Earth again. Within a single human lifetime, we moved from deafening broadcasts to hushed fiber lines and tight-beam internet satellites. As efficiency grows, the stray signals that once leaked into space shrink. If this trend continues, our detectable era may end before 3 centuries have passed. 1,000 years from now, Earth might be electronically quiet, humming on glass threads beneath ground and sea. To distant watchers, that would make us a sudden flare that vanishes as quickly as it came. Galactic colonization, if it ever occurs, faces its own time limits. A patient species might launch slow craft to nearby stars. Each colony, after a few generations of building, sends new ships farther out. Even at modest speeds, such a culture could settle the entire disk in a few million years, an eye blink compared to stellar ages. Yet the same internal forces that drive expansion can reverse it. Politics shift, resources wane, curiosity fades. Colonies might declare independence, then forget the mother world. The wave of settlement stalls, coasts, and eventually recedes. What looked like a permanent empire becomes a brief pulse of migration, leaving ruins that outlast the living. Now add the steady drumbeat of stellar lifetimes. Sun-like stars burn for roughly 10 billion years. As they redden and swell, any civilization tethered to their warmth must migrate, adapt, or perish. Those that survive must reinvent themselves, perhaps abandoning planets entirely. Such transitions are risky. A culture may choose hibernation, descending into digital archives stored between stars, waiting for a new class of suns to form. Detectable radio traffic would dim, replaced by low-energy whispers or silence. Given these short windows, coincidence becomes rare. Picture two coins dropped onto a calendar that stretches kilometers in both directions. Each coin covers 1 square centimeter. The chance that they land on the same day, even the same hour, is tiny. Now imagine millions of coins, each representing a civilization. If every coin covers only a fraction of a second near midnight, overlap is no longer the rule but the exception. Statisticians call this the problem of coincident phases. Even with generous guesses, billions of worlds, thousands of technological species, the briefness of their bright periods keeps the galaxy mostly dark. A simple equation captures the idea without numbers. The fraction of time you can be heard, divided by the age of the galaxy, multiplied by the number of possible minds. When the first term is a spark and the second is an ocean, the product stays small. We expect echoes, yet hear none, because the echoes miss us by an inch of eternity. This insight softens the Fermi question. No vast conspiracy is required. No cosmic quarantine. Only the ordinary truth that moments rarely agree. Two dancers pirouette on opposite sides of a dark stage, each under a spotlight that fades before the other begins. To us, the audience, the house appears empty. Still, the possibility of alignment remains. A distant array of antennas might swing across our sun's spectrum tomorrow, catching a burst of television from the 1960s. Or our own telescopes, tuned to new frequencies, might record a carrier wave that began its voyage when saber-toothed cats roamed North America. Such a discovery would tell us nothing about the sender's present state. By the time their greeting arrives, their civilization may have entered quietude or transformed into something beyond recognition. We would share the cosmos as ghosts share a corridor, aware, yet unable to touch. Contemplating this mismatch invites a humbler view of progress. We speak of the future as though it were a wide plain stretching endlessly ahead. In cosmic terms, the future is a narrow bridge. Crossing it demands sustained curiosity, cooperation, and luck. If we manage to keep our light on longer than average, we might become a beacon for others entering their own brief dawn. Even if we never reply, the record of our existence, our songs, our science, the color of our skies, could ride the vacuum and greet minds whose morning lies a million years after our sunset. Until then, patience is our only companion. The galaxy's story is still being written. Pages turn slowly. A chapter that begins today may not be read by another intelligence until Earth is a memory wrapped in drifting strata of rock. If so, let us try to make this chapter worthy of the wait. Out beyond the orbit of Mars, where sunlight grows thin and the planets turn slowly, a quiet machine keeps watch. Its mirror is twice as wide as a city bus, its eye so sharp it could spot a candle on the moon. We call it the Roman Space Telescope, after the woman who mapped the sky long before rockets ever left Earth. It has not yet launched, but its twin, already folded inside a clean room in Maryland, glows beneath soft lamps like a sleeping bird. When it wakes, it will begin the widest survey of galaxies ever attempted, and almost as a side note, it will test a new trick, blocking starlight so completely that any nearby planets slip into view. If a sister Earth circles Alpha Centauri, Roman may see its oceans shimmer. If an industrial smog hangs over that world, Roman may taste it. No alien radio call is required. A single pixel that flickers between blue and brown could be enough to tell us someone else has built, and perhaps thought, and perhaps dreamed. Yet even Roman is only a rehearsal. Climbing the drawing boards now are mirrors 10 times wider, made of fold-up petals so thin they feel like parchment. Launch one of those into the shadow of Jupiter, let it drift 4 times farther than our moon, and the sun itself becomes a lens. Starlight bends around the craft, focusing into a spot no larger than a tennis court back near Earth's orbit. In that spot, astronomers could count continents on a world 50 light-years away. With luck, they could watch nightlights sparkle on the dark side, the way astronauts watch Karachi or Chicago from orbit. A planet-wide grid would look different from volcanoes or auroras. Patterns betray minds. No message need be aimed at us. A city simply glows and the universe tells its own story. While engineers polish mirrors, other teams choose humbler tools. A radio dish no bigger than a trampoline, parked on the far side of the moon, listens in perfect silence. Earth's cacophony of phones, satellites, and power lines cannot reach there. During the long lunar night, the dish eavesdrops on the galaxy at the quietest frequencies. If a civilization leaks the radio equivalent of airport radar, the lunar ear may catch it. The cost, less than a single fighter jet. The reward, a voice older than any nation. Between these giants and midgets lies a middle path. A fleet of 1-meter telescopes, scattered like chess pieces across the globe, can link into a single Earth-sized eye. No rocket required, only fiber-optic cables and patience. Such an array could resolve the raised lettering on a cargo ship orbiting Neptune, were any there. Turn it outward, and the laser flash of an alien starship could be seen across the spiral arm. Turn it inward, and we study our own planet with new humility. Every forest fire, every algal bloom, every city grid reminds us how loudly we broadcast without meaning to. The same instruments that hunt for others also teach us to tread more gently here. All these machines, however, are only metal and glass until people give them purpose. In a converted warehouse in Berkeley, graduate students from Lagos, Mumbai, and Sao Paulo meet over coffee. One is a linguist who once studied whistled languages in the Canary Islands. Another codes neural nets that dream up imaginary alien alphabets. A third brings soil samples from the Atacama, teaching computers to recognize life when it barely breathes. None grew up building rockets. All now share a single tax-funded server rack that sifts signals from the southern sky. Their weekly seminar is held in English, Spanish, and Python. Their common tongue is curiosity. This is the new face of SETI. Less a lone astronomer on a mountaintop, more a global potluck where biologists, artists, and coders trade recipes for questions we do not yet know how to ask. Even if every telescope finds nothing, the effort changes us. Consider the Voyager record, a copper disc plated with gold, riding a spacecraft that will never land. On its surface are greetings in 55 tongues, from Akkadian to Wu. The words are simple: hello, peace, friendship. Yet they took years to choose. Committees argued whether to mention war, disease, or death. In the end, they decided to speak mostly of music. The disc carries blind Willie Johnson moaning dark blues, a Japanese shakuhachi breathing like wind through bamboo, and the brain waves of a woman newly in love. No single nation could have written that playlist. The project forced engineers, ethnomusicologists, and storytellers to sit at one table and admit how little they knew about one another, let alone about beings who might have 3 ears or none. The search for others always loops back into a mirror. What do we want to say, and why, and who gets to speak? Perhaps, then, the most urgent instrument is not a mirror but a question mark. How shall we behave if we are small and young and possibly alone? Some answers lie closer than Orion. Beneath Antarctica's ice, microorganisms live their whole lives in liquid brines colder than your freezer. They eat rock and breathe iron. They divide once a century. To them, a human lifetime is a lightning flash. Yet their chemistry is our chemistry, the same spiral alphabet of DNA, the same trade of electrons for energy. If life can bloom in such hidden gardens, the galaxy may bloom everywhere. But if, after 4 billion years, that life never advanced beyond single cells, intelligence may be the rare ingredient, not life itself. We might be the first to wake, the first to wonder, the first to worry. That thought steadies the hand that holds the drill. Every meter we bore into oceanic crust, every cloud we seed, every species we bring back from the brink is rehearsal for stewardship on a scale we have never needed to name. Imagine a civilization that survived its own fossil fuel summer. They learned to keep their planet's thermostat within 3 degrees for 10,000 years. They buried carbon not in landfills but in basalt, turned farms into sponges for rain, and let half the globe remain wild. They never invented starships, but they never needed to flee. Their greatest monument is a stable atmosphere. If such a world orbited Tau Ceti, our telescopes would see no pyramids, no beacons, only the faint spectral signature of methane kept oddly low. A breath balanced, a mature planet, a signpost readable across centuries. Here lived a people who learned to stay without exhausting the gift. We are not yet that people. Our fingers still drip with oil, our languages still hold more words for growth than for enough. Yet every year another coal plant closes, another marsh returns, another girl who once hunted firewood in Kenya codes her first app on a second-hand phone charged by the sun. The curve bends slowly. If ever we meet others, they will ask not how tall our rocket stood, but how long we kept the only garden we knew alive. And if no one ever asks, the garden is still worth tending. The question of loneliness is also the question of legacy. Someday, maybe centuries hence, a probe no larger than a birthday cake will unfurl a sail thinner than a butterfly's wing. A laser stationed on the dark side of Earth will track it like a lighthouse. In 10 minutes, the craft will reach 1/5 the speed of sound. In 20, it will outrun the fastest rifle bullet. After 20 years, it will streak past Proxima Centauri, snapping photos of a red dwarf star and any planets caught in its crimson glare. The images will take 4 years to crawl home at the speed of light. Who will see them? Perhaps a teacher born the year the probe left, now retired, showing her class a pixelated dot that might be sunrise over another world. The children will ask if anyone lives there. The honest answer will still be, we do not know. But the search itself will have carried a quiet message. Someone cared enough to look. Until that day, we listen, we look, and sometimes we speak. A simple pulse of light, sent from a telescope in the Canary Islands in 2009, carried 501 drawings by schoolkids. The beam left at the speed of light, racing past Pluto, past the heliosphere, into the open ocean. In 2070, it will cross the disk of stars we call M13, a globular cluster where hundreds of thousands of suns crowd within a few light years. If anyone there owns a modest mirror, they might catch a glimmer. The drawings are cute, a fish wearing sneakers, a girl flying a kite on 2 moons. Yet the gesture is serious. It says, we know how brief we are and still we choose to wave. Every such message is a small wager against forgetting. If no hand ever returns the greeting, the wager costs nothing but the electricity to fire a laser for a minute. If a reply ever comes, the payoff is shared by a species suddenly larger than itself. Between the sending and the receiving lies the longest pause. How shall we live inside it? Maybe by holding two thoughts at once. First, the cosmos is vast, old, and mostly silent, so silence is the safe bet. Second, every story we love began with someone doing the unsafe thing, leaving the forest, tasting the blueberry, sailing beyond the edge of maps. The paradox is not really about aliens. It is about us here now, deciding what kind of ancestors we want to become. If we choose stewardship, curiosity, and the humility to wait decades for an echo, we may earn the right to hear one. If instead we choose haste, extraction, and the loud certainty that nothing out there matters, the silence will remain perfect, and we will have filled it with our own ending. So the next time you stand under a dark sky, let the starlight settle on your face like slow rain. Each photon left its sun before your first word, before the first pyramid, before the first campfire. It has traveled the length of history just to land on your cheek. Notice how gently it arrives. No fanfare. Only the quiet suggestion that something once shone and someone, maybe, is still shining. Hold that thought, and the night feels less like an emptiness and more like a room where conversations have only just begun. We may arrive early or late or exactly on time. The only way to know is to stay curious, to keep listening, and to walk softly on the only world whose heartbeat we can feel beneath our feet.